Hello everyone, welcome to Lessons with Philip. And today our topic will be centered on trigonometry. Now trigonometry deals with solution of triangles and the relationship between angles and the size of a triangle. Now in our previous classes we have dealt with angles in a triangle and how to solve them. Now we want to bring a relationship between the angles of a triangle and their size. And don't forget that we said there are different forms of triangles. We have right angle triangles, we have right angle isosceles triangles, we have isosceles triangles, we have obtuse triangle, we have equilateral triangles, we have scaling triangles, and so on and so forth. Now, depending on any type of triangle, now there are four general formula to solve angles and size of triangle. One of it is trigonometrical ratio, which we are going to consider today, and that one is Pythagoras theorem. We have Pythagoras theorem. Okay, we have Pythagoras theorem. We have what we call sine rule, and lastly, we have what we call cosine rule. Now, if you are given a right angle triangle, you can only use trigonometrical ratio and Pythagoras theorem. Now, if any other triangles other than right angle triangle, you're going to use either sine rule or cosine rule. We're going to go deeper on how you know that you need to use sine rule or cosine rule. How do you know that you need to use Pythagoras theorem or trigonometrical ratio? All right, let's go. Let's start with trigonometrical ratio. Now, trigonometrical ratio is all about sine, cosine of a triangle, tangent of a triangle, and sine of a triangle. That is why in our junior classes, when we're young, we're told to always remember what we call so, ka, tua. All right? All right? Don't forget we said triangle has three sides. Now, all those three sides has the name. Okay, let me say I represent a triangle, a right angle triangle. Don't forget, trigonometrical ratio is all about right angle triangle. Now, let me name the triangle as triangle A, B, and C. Okay, now assuming, because in my question I have alpha here. Now, assuming I call this place alpha, okay, assuming I call it alpha. In a triangle, in a right angle triangle, any side that faces the right angle is known as hypotenuse. Okay, now with this labeling of this triangle, this will be my side A, this will be my side B, because this side faces this angle B. So this will be my side C. Okay, now in this diagram, automatically, if I'm asked to find angle B or angle C or angle A, I have to use what we call my SOHCAHTOA. My SOHCAHTOA says sine equals opposite over hypotenuse. So sine, so if I'm considering this angle now, what side faces this angle? It is this side. So this side will be opposite. Okay? And this side will be adjacent. Now take note, your opposite and adjacent changes depending on the angle in view. If I'm considering this angle, that shows that this side which faces this angle will be my opposite. Do you get it now? Okay, now sine of this angle, sine theta, or sine alpha rather, pardon me, sine alpha will be equals to, don't forget, opposite over hypotenuse. My opposite in this triangle is what? B. That is B over what? Over A. Okay? Now, my tan alpha, tan is what? Opposite over adjacent. My opposite is what? Is B, and my adjacent is C. Now, my cosine of alpha, cosine is what? Adjacent over hypotenuse. My adjacent is what? Side C, and my hypotenuse is side A. Are you going? Are you following me? Now, if I want to, don't forget in our previous classes, we have said that all the angles in a triangle, this place, and this place, angle A plus angle B plus angle C will be equal to 180 degree. Sum of angles in a triangle. Okay, you can check our previous videos to understand this theorem. Okay, now if these three angles are equal to 90 degrees, now and this only A, our angle A is 90 degrees because it's a right angle triangle, because this triangle is a right angle triangle. So this my A is 90 degrees. Automatically, this B and C, my angle B plus my angle C is equals to 90 degrees, because this one is alone is 90 degrees and the three at 180 degrees. That shows that if I have these two together, it will be equals to 90 degrees. So, and this theorem says this is complementary angle. That shows that B is complementary to C. Complementary angles. Okay, you can check my previous video to understand this theorem also. Now, if these two are equals to 90 degrees, that shows that this place will be equals to 90 degrees minus alpha. Okay, now that shows that I can change my triangle to say that I have this place to be A, this place to be B, okay, this place to be C. Okay, this is still my small letter C, side A, and side B. Okay, if this is theta, this will be what? 90 degrees minus alpha. Okay, so this angle will be 90 degrees minus alpha. So if I want to find this angle, now I want to consider this angle. So this will be my opposite, and this will be my adjacent. This side face the right angle, it will still be my hypotenuse. So if I want to find this angle will be what? Sine of this angle, which is 90 degrees minus alpha, will be equals to, don't forget, sine of an angle is opposite, still remain the same, over hypotenuse. In this case, my opposite is what? C, and my hypotenuse is A. If I want to find my tan of this angle, 90 degrees minus alpha, my tan is opposite over adjacent. My reference point is this. Tangent is equals to opposite over adjacent. So in this diagram now, my opposite is still my C and my adjacent is my B. So if I want to find cos of 90 degrees minus alpha, don't forget cos is what? Adjacent over hypotenuse. And in this diagram, my adjacent is what? B, and my hypotenuse is A. If you have gotten into this point, you will observe that we have one of them that have equals. We have B over A. Do we have anyone that has B over A? This. That shows, from this diagram, that shows, please take note, that shows that in any diagram, my sine alpha equals, which is B over A, is equals to my cos 90 degrees minus alpha. Take note of this. This is a general statement. In any sine alpha, which is B over A, you can see they are both equals to B over A. They are both equal. That shows that when you are given any diagram, the sine of this angle will be equals to cos of this angle. Simple as ABC. The sine of this angle equals to cos of this angle. Okay? All right. Now, the sine of this angle equals to the cos of this angle. Simple as ABC. All right. Now, let's check again. Let's see if we have something that's equal again. We have C over A. Do we have anyone that is C over A again? You can see C over A. That shows also that sine of 90 degrees minus alpha equals cos of alpha. Do you get that? Which is equals to C over A. That shows that cos of this angle equals to sine of this angle. Sine of this angle equals to cos of this angle. And that is what we have tried to prove here. Now let's go to our question. We are given to solve cos of alpha equals to sine 40 degrees. Always remember that cos of this angle, cos of alpha, do we have anything? Cos of this angle equals to, note that cos alpha equals to sine 90 degrees minus alpha. So wherever in your question, wherever you have cos of alpha, what will you put? You just substitute this there. So you remove this, you put this. So therefore, sine 90 degree minus alpha is now equals to sine 40 degree. I've just removed this and I replace with this. Okay? So you can see they both have sine. So sine can remove. So we have 90 degree minus alpha equals to 40 degree. So you can do your mathematics. Bring your 40 to this side. We have 90 degree. If 40 degree comes to this place, it becomes minus. Minus 40 degree equals to alpha. If minus alpha comes to this, it becomes positive. So therefore, my alpha equals to what? 50 degree. If you press your calculator, put your alpha to be 40 degree, 50 degree. Go and press cos 50 degree and go and press sine 40 degree. You will see that they're equal. In my coming videos, we're going to do more of this example so that you understand better. Kindly subscribe and like my videos. See you in my next video. Thank you. Bye.